Hello guys, this is Srikar. In this video we will see how to do linear regression via statistics method. Actually I made a video on this topic before, but in that case I used virtual voice, but I already uploaded in YouTube. You can check that video. But I'm again making same video with my own voice, and later upcoming videos also I will use my own voice only in this ML series. So in this video we will see how to do linear regression via statistics method. Actually, we can do linear regression with different methods also by using normal equation, gradient descent, batch gradient, stochastic gradient. We will see in the upcoming videos those stuff. So what is linear regression? Linear regression is a linear approach to modeling the relationship between a dependent variable and independent variable. If we have one independent variable, then it is called simple linear regression. Otherwise, if we have more than one independent variable, then it is called multiple linear regression. In this video, we are going to see with one independent variable. In the next video, I will explain you with more than one independent variable. Here is the function y equal to m1 x1 plus m2 x2 plus and so on mn xn plus b. Here n is called number of independent variables. Like if I have to pass the x values and it will predict the y value. Here y equal to mx plus b. It is a line equation. So we are going to find m and b values. How to find m value, and m is called slope. How to find m value? It is the formula summation of m times x minus x mean into y minus y mean divided by summation of m times x minus x bar whole square. Like actually here summation of m times means m is called number of training examples. That is different from the slope m. Here b is called bias. B equal to y mean minus m into x mean. Let's see how to do code. Let's start. First I'm going to import the required libraries before starting the main process. First I'm importing numpy as np, import pandas as pd, import matplotlib.pyplot as plt. From matplotlib import style.use 538. Here I am using the style called 538. It is the one of the style in the matplotlib. Next import warnings. By using the warnings we can actually ignore the warnings like update warnings, those things. Warnings.filter ignore, and finally importing the cbone also. First I am reading the dataset. In this video I am going to take someone's dataset called salary versus number of years experience dataset. Let's load the dataset. pd dot read underscore csv salary dot csv data dot head. See, this is our dataset. Like dot data head means it retrieves the first 5 training examples from the dataset. Here y number of years of experience, and here salary, age, company change, type. But in this video we are going to take only first 2 columns, number of years of experience and salary, and we will drop the remaining columns. First let's drop the remaining columns. Data dot drop method. Let's open the bracket. Age and company change and type. These are in the axis 1 and we are keeping the in place equal to true. Now see our dataset, data dot head. See, we are dropped the age, company change and type columns. Let's see some info of the data in data dot info. Here we have 30 training examples with 2 columns. Next we will see some statistics of this data. Data dot describe dot transpose. By using the describe method, we can see the some statistics of this data set, like number of count, mean, standard deviation, like this. Next let's see, is there any null values in our data set. Data dot isNull. By using the isNull, can check is there any null values in our data set. We have 0 null values, so we can easily proceed to further. Now see correlation. Data dot cor. So we have high correlation. For example, what is correlation? Like basically correlation says about the strong relationship between the two variables. For example, here take years of experience versus years of experience and salary. Here years of experience and salary relationship is 0.9782. Like if the number is very nearly to 1, means that both variables in strong relationship, means highly correlated. If they are close to minus negative 1, then in that case also they are highly strongly correlated with each other. If it is in 0.1, like minus 0.1 in that range, means those both variables are lessly correlated. I mean less strong relationship between those variables. Now see the heat maps of this correlation map. PLT dot figure fix size equal to 10,6. SNS dot heat map data dot correlation vertical labels equal to false, anode equal to true, cmap equal to capital G small n capital B small u underscore r. Actually here cmap is a style, so by changing the cmap we can visualize the heat maps in different styles. It is called heat map. Correlation 1 and 0.98 as we seen here. Next, similarly heat map we can visualizing cluster maps also is there in the Seaborn. Let's see that thing. Next I'm copying that thing. SNS dot cluster map data dot correlation cmap equal to lag anode equal to true. It is called cluster map. Now let's see some distributions between the variables years of experience and salary. I am pasting the same thing. plt dot. Here in this plotting I am creating two subplots. One is for years of experience and another is for salary. Plt dot subplot 121 sns dot list plot data years of experience, comma, color equal to red. Similarly, I am copying this thing. Here I am changing this, plot. Here I am keeping the 122 subplot. Salary, I am keeping it to green color. Sorry. Subplot not 0. Oh, this one also changed. Like it shrinks, right? So I can expand this thing. 13,6. So you can clearly see the distribution of this data, like years of experience. In our dataset, at the range of years of 4 years of experience have high numbers. Now this is the salary distribution. In the next plot, we will see violin plot. Similarly, I am copying this whole thing and pasting. Just I am changing this thing. This is called violin plot. Like here we have wide range. See. In the next plot, we will see some dense plots. Plt dot figure fixed size equal to 13,6. Plt dot subplot 121. Here dense plot means by using the KDE plot we can plot these things. KDE plot data years of experience, comma, data salary, comma, color equal to green. Again I am copying this thing, change this thing. Here I am keeping the shade for the second subplot. Shade equal to true. Like see here we have more density. This is the salary versus years of experience. In the next plot we will see some scatter plots. I am copying this thing. SNS dot scatter plot x equal to salary, comma, y equal to years of experience, data equal to data. Here S is called size actually. Something we got here, some name error we got. Let me copy this. This is the scatter plot of our data years. So this is the in the y-axis. It is the years of experience and it is salary. Here we can fit the line here. That is the function. Like Cbond actually provides some built-in fit lines. Actually, it fits the line according to the data. We will see that is called lm plot. Plt dot figure fix size equal to 13,6 sns dot lm plot. I'm copying this thing. See, it already fits the line to our data. So now we are going to divide our dataset into two parts. One is for training part and another one is for testing part. Here I am going to give 70% of the data for training part and another 30% of the data for testing part. Well, let's write code for that. From scalar dot model selection import train test split. I'm going to divide our one independent variable and another dependent variable into x in the form of x and y. X equal to np dot array data into text salary in the y variable equal to np dot array data years of experience. Now let's divide our dataset. Let's create x train, comma, x test, y train, comma, y test equal to train test split x comma y comma. I'm giving random state of we can give any random number. Based on that random number, it shuffles the training set and it splits into this training set and testing set. Random state equal to I'm giving 32 number. We divided our dataset. Now we apply those formulas for this dataset. These are the formulas we required. I'm creating a variable called a x train minus x train dot mean, and another variable I'm creating. Here I'm taking this c variable because here I'm not taking the b variable because you will confuse because here b is called bias. So I'm not gonna taking the b as a variable anywhere. Y train minus y train dot mean. Next d equal to summation of a into c. Summation of a into c. Next e equal to summation of a into a. M equal to like d divided by e. Finally we got the ML. Now we have to do for b value bias. That's b equal to y train minus m into y train dot mean minus m into x train dot mean. Now we have print those slope and bias values. slope is m, bias is b. Let's see, here we got slope is 9.899 and bias is minus 2.2. Let's predict the y test values, sorry, x test values. I predict equal to m into x test plus bias. Let's compare our results with our original values and the prediction values. Print y predict print y test. Here we got the values. Here first we got prediction is 1.6 but actual value is 1.1, and next one is 3.3 but we got 4.1, next one is 3.6, we got 3, next one is 3.3, like that going on. Let's see how our model is fitting. Let's plot our final graph. Here first line is we are setting the figure size, and here we are plotting the x test and y prediction with marker O and color blue and marker face color with red, and marker size is 10, and line style is dashed, and we are scattering the x and y points also. This is our graph. It is the years of experience and it is the salary. Like our model, our line is fitted exact, like somewhat better. Let's see the accuracy of our model. From scalar dot metrics import explained variance score. Actually there is a 5 metrics are there for calculating the error, but now I'm using the explained variance score. In the later videos I will use remaining metrics also, and I will make a video on the metrics from scratch. I will explain 5 metrics in that video. Explained variance score, y test comma y prediction. Here you got 96% accuracy, like into 100. We got 96.04% accuracy. Like if we consider the remaining variables also, maybe our model can increase the remaining, like we can increase somewhat accuracy, not very much but somewhat. Okay, thank you guys. I hope you like this video. I will continue this series, ML series. Please subscribe to my channel. Thanks. And daily I will upload some content on AI in my Instagram channel, so you can follow me in Instagram channel also, and you can contact me separately also. So I will reply to everyone if they have any doubts. Definitely. Thank you guys.